Let's prove Theorem 1.2. Here Theorem 1.2 says that let P be a prime number. If P divides A square, then P divides A, where A is a positive integers. Here we know that the prime numbers are the numbers which has exactly two factors. The type of numbers are known as the prime numbers. Here P is a prime number. If this P divides A square, then that P will also divide A. This A is a positive integers. This means that if we are given with the number 2 and this 2 can divide, if this 2 can divide 2 square divided by 2, then this 2 will divide 2. So let's prove it. First, we know that every positive integers can be expressed as the product of primes. This statement we know it from the fundamental theorem of arithmetic from Theorem 1.1. So let's consider let A equal to P1 into P2 into P3 into ... Pn. Here we are considering these positive integers with A and the expressions as the product of primes with P1 into P2 into P3. So here P1, P2, P3, Pn are all the primes, not necessarily all distinct. This means that this can be 2 into 2 into 2 into 2 or something like it, 2 into 3 into 4 into 5, not 4, 2 into 7 into 5, something like that. This means that. Next is squaring both sides, we get. If I square this one, we get A square. If I square this one, we get P1, P2 into P3 into ... Pn into P1 into P2 into P3 into ... Pn. If I multiply this one, we get P1 into P1, we get P1 square. P2 into P2, we get P2 square. P3 into P3, we get P3 square ... Pn into Pn, we get Pn square. Now we are given that, here we are given that P divides A square. So now we are given that P divides A square. Therefore, from the fundamental theorem of arithmetic, it follows that P is one of the prime factors of A square. This means that if we are given with P divides A square, then this P will be one of this one. It may be P1 or it may be P2 or it may be P3 or it may be Pn. We know this from the fundamental theorem of arithmetic. However, using the uniqueness of the fundamental theorem of arithmetic, we realize that the only prime factors of A square are P1, P2, ... Pn. We now realize that the prime factors of A square will be P1, P2, P3, ... Pn. So P is one of the P1, P2, P3, ... Pn. So P is one of these following. Here this P1, P2, P3 are what? P1, P2, P3 are A. Since A is equal to P1, P2, P3, Pn. So P divides A. P divides A. Here it finishes the theorem.